So today we're going to be talking about an RAPD, Relative Afferent Pupillary Defect. And an RAPD means you have a defect in the pupil pathway, but not on the efferent side, the afferent side. The afferent side is the sensory going towards the brain. The efferent side is away from the brain. The efferent fiber for the pupil is the sympathetics and the parasympathetics. That's carried by cranial nerve 3 for the parasympathetics, and the Horner syndrome is what you get with the sympathetic lesion. We're not going to be talking about efferent. We're only talking about afferent. It's detected as a relative afferent pupillary defect because it is the relativity to the fellow eye that defines the RAPD. So in order for you to know what an RAPD is, you need to know a little bit about the anatomy of the afferent pathway for the pupil. And so we're just going to cover that right now. So this is just a schematic drawing demonstrating that the retina is where the light first hits the afferent pathway for the pupil. Then the pupil pathway carries the light reflex down the optic nerve, down the optic tract, and before getting to lateral geniculate body, the pretectal neuron comes off the optic tract, and then it travels to the efferent pathway. And the efferent pathway begins with the Edinger-Westphal nucleus and then is carried on cranial nerve 3 to the ciliary ganglion, and that is the efferent pathway. So if we have a defect in the pupil pathway on the afferent side, we can detect this defect by comparing the light response in both the eye that receives the light, which is the direct response, and because the pretectal nuclei innervates both Edinger-Westphal nuclei, we have a consensual response in the fellow eye. So let's just schematically diagram this out. So here are the pupils, and if we shine the light on the pupil, in this case the right pupil, both pupils will constrict the light. This is the direct response, and because of the pretectal neuron connecting both Edinger-Westphal nucleus, the other pupil will constrict, the left pupil. So both pupils constrict when we shine the light, because there's a direct response, D, and a consensual response, C. If we swing the light from the right eye to the left eye, if both pupils are normal and the afferent system is intact, nothing will happen. But if there's damage to the left pupillary pathway, when we swing the light from the right to the left, both pupils will dilate. And when we see that, that indicates there is a defect in the pupil pathway on the afferent side relative to the fellow eye. Because now the direct response in the left eye is less than the consensual response in the right eye. That sign, RAPD, tells us that we have an APD. The relative afferent pupillary defect is a sign that there's a defect in the pupil pathway on the afferent side. That means we have a defect somewhere in the pupil pathway. And vice versa. If we have no RAPD, that means we have either no defect, or you have a defect, but it's not in the pupil pathway, or you have a defect in the pupil pathway, but it's not on the afferent side, or there's no R relative to the fellow eye. There's no defect detectable. So let's just give these examples so you can see why someone would have no RAPD. Number one, you might not have a defect. Either the defect is not present, there's nothing wrong with this person, or you didn't detect it properly because you don't know how to do the tests. It could be a problem in the afferent pathway, but not in the pupil. So anything in front of the retinal ganglion cell, cataract, cornea, glasses, tear film, that doesn't affect the pupil pathway because that's in front of the pupil pathway. In addition, anything from the geniculate body through the radiations and the cortex also will not produce an RAPD because this is posterior to the pupil pathway. So you could have no RAPD and have real organic vision loss either from a lesion anterior to the pupil pathway, cataract, glasses, cornea, or posterior to the pupil pathway, behind the optic tract. You could also have no relative. If you have bilateral and symmetric disease, then both pupils will be equally affected and you will not be able to detect an RAPD even though they have an APD. They have a defect in their pupil pathway on the afferent side, but because it's bilateral, you don't have the R. Relative to the fellow eye, you don't detect it. So the absence of the RAPD means you either have no D, no defect is present, or it's not a defect in the pupil pathway. It's not afferent disease, or relative to the fellow eye, you can't detect it. In addition, you need to know that the lesion can affect not just the retina, the optic nerve, the chiasm, the tract, but also this pretectal nuclei. And this is called a tectal RAPD. A defect in this interneuron, which connects the tract to the Edinger-Westphal nucleus and cranial nerve 3. If you have a lesion in your dorsal midbrain, it can produce an RAPD with no vision loss, because the visual pathway already went to the geniculate and is on its way to the radiations and the cortex. So you can have an RAPD with 20/20 acuity, a normal field, a normal fundus examination, and a normal OCT, and that is called the tectal RAPD. In addition, you need to know that you can detect the RAPD as long as you have 2 eyes and at least 1 working pupil. You have to have 2 eyes because it's relative to the fellow eye. But what if one of the eyes has an efferent pupillary problem as well as an afferent pupillary problem? So in this particular example, let's pretend that the left eye has a fixed and dilated pupil because it has a third nerve palsy, a pupil-involved third nerve palsy, or you could say the iris was damaged from surgery, or they have an adhestonic pupil, or some other efferent cause of a pupil to be dilated. In that setting, there'll be anisocoria. When we shine the light in the right eye, the right pupil will constrict, but because the left pupil is fixed and dilated, it can't do anything. But I still want to detect whether there's an RAPD in the left eye, an afferent defect. So when I swing the light from the normal right eye to the abnormal left eye, of course this one's fixed and dilated, so it doesn't do anything, but we can look at this right pupil. And so if there's an RAPD in the left eye, we can see the dilation of the pupil on the right when we swing the light from the right to the left, and that we call reverse testing of the RAPD, reverse. But there's nothing reverse about it. It happens every single time, you're just not looking at that eye. So to detect an RAPD, we only need 1 working pupil, but we have to have 2 eyes. And I hope this makes RAPD a lot easier for you.